Welcome to this video on the topic of graph traversal in DSA, in this presentation that you will actually understand. Here's what we will be covering in today's course. We will first introduce ourselves to graphs and their applications, and then look at how we access data in graphs through traversal using two methods: breadth first and depth first search traversals. Let's look at this relation set. There are four friends, we'll be calling them A, B, C, and D. A is friends with B, B with C, C with D, and D with A. How can we organize this data more efficiently? Of course, with the help of graph data structures. Using graphs we can represent this as a network, instead of individual data elements. Consider a social network where all A, B, C, and D are each other's friends. This is how it would look like. The nodes represent the data elements and the edges represent the relationships between them. A graph is a fundamental data structure in computer science and algorithms that represents a collection of nodes, vertices, and the connections between them, edges. It is a versatile and powerful tool for modeling various real-world scenarios, making it an essential concept in data structures and algorithms. Now let's talk about graph traversal. There are two primary methods. 1. Depth first search, DFS, and 2. Breadth first search, BFS. The breadth first search, BFS, algorithm is used to search a graph data structure for a node that meets a set of criteria. It starts at the root of the graph and visits all nodes at the current depth level before moving on to the nodes at the next depth level. It utilizes a queue data structure to keep track of the nodes to visit next. All the adjacent unvisited nodes of the current level are pushed into the queue and the nodes of the current level are marked visited and popped from the queue. Let's try to understand BFS for the graph given on your screen. First, we shall initialize an empty queue and array of visited elements. Then upon starting, we push 0 into the queue. Upon having visited it, we remove it from the queue and add it to the array. The red nodes are the nodes we have already visited. When it's their turn, add nodes 1, 2, 3, and 4 to the stack. Then, remove node 1, 2, 3, and 4 like we did before upon visiting them by popping them from the queue and enter them into the array. When the queue is emptied out, and all the elements have been visited, we shall terminate the iteration process. Now before we head towards understanding the actual code of the DFS, let's first look at its algorithm if we were to write the code in Java. We would be taking an input using an adjacency list data structure, and a starting vertex, which would be where we would start traversing from. The output shall be the order of BFS traversal of all the given nodes. Our functional procedure is to 1. Create a Boolean array visited of size v, the number of vertices in the graph, and initialize all elements as false. This array will keep track of visited vertices. 2. Then we will create an empty queue to store vertices for BFS traversal. 3. Mark the starting vertex as visited and enqueue it into the queue. Now we shall look at two conditions. For while the queue is not empty, repeat the following steps. A. Dequeue a vertex from the queue and print it, or perform any desired operation. B. For each adjacent vertex ADJ of the dequeued vertex, do the following. If ADJ is not visited, i.e., visited ADJ, is false, mark it as visited, set visited ADJ to true, and enqueue ADJ into the queue. Continue step 4 until the queue is empty. Pause and take a look at this code to implement BFS traversal on your graph data structure. There are comments in the code to help you understand it further, and feel free to ask questions in the comments. Next, we shall be covering DFS, or depth first traversal. Depth first search, DFS, is a graph traversal algorithm that explores as deeply as possible along a branch before backtracking. It's used for tasks like pathfinding, cycle detection, and connected component analysis in graphs. It is often implemented using recursion or a stack. But, how does DFS traversal work? Depth first search is an algorithm for traversing or searching tree or graph data structures. The algorithm starts at the root node, selecting some arbitrary node as the root node in the case of a graph, and explores as far as possible along each branch before backtracking, which is what makes it different from BFS. Let's try to understand DFS for the graph given on your screen. First, initialize an empty stack to perform push and pop operations for the elements to be visited. Remember, the last one in shall be the first one out. Step 2 is to visit 0 and put its adjacent nodes, which are not visited yet, into the stack. Now, node 1 at the top of the stack, so visit node 1 and pop it from the stack and put all of its adjacent nodes, which are not visited, in the stack. Now, still continuing along the node, backtracking it, node 2 at the top of the stack, so visit node 2 and pop it from the stack and put all of its adjacent nodes, which are not visited, i.e., 3, 4, in the stack. Similarly, now, node 4 at the top of the stack, so visit node 4 and pop it from the stack and put all of its adjacent nodes, which are not visited, in the stack. And now finally, node 3 at the top of the stack, so visit node 3 and pop it from the stack and put all of its adjacent nodes, which are not visited, in the stack. Now we have an empty stack, which means that we have successfully traversed through all the elements and can terminate the process. Congrats! You just learned 2 methods of traversing. Now let's take a final push and learn how to implement it. But again, before jumping straight into the code, let's take a look at the algorithm. We shall have an input of a directed or even undirected graph. This will be represented using an adjacency list. We will also input a starting vertex to begin the traversal. And the output we shall get at the DFS traversal order of the vertices or nodes. The ultimate procedure is to first create a Boolean array visited of size v, the number of vertices in the graph, and initialize all elements as false. This array will keep track of visited vertices. Then define a recursive function, DFS recursive, that takes the current vertex as an argument. Mark the current vertex as visited by setting visited, current, to true. Print the current vertex, or perform any desired operation, and, for each adjacent vertex adj of the current vertex, do the following. If adj is not visited, i.e., visited adj, is false, recursively call DFS recursive adj. Finally, start the DFS traversal from the given starting vertex by calling DFS recursive start vertex. Here's the code for DFS traversal of a graph in Java. Pause and take a look at this code to implement BFS traversal on your graph data structure. There are comments in the code to help you understand it further, and feel free to ask questions in the comments. I hope you liked this video presentation about graph traversal in DSA. Thanks for watching, and I hope you paid attention.